Hello everyone, in this lecture we'll talk about diagonal matrix, upper triangular and lower triangular matrices, and also we'll talk about the symmetric matrix. So we define the diagonal matrix as a matrix that has zeros of the main diagonal. So it has some numbers here at the main diagonal, but the only condition is that all these elements of the main diagonal are zeros. So all these elements must be zero. For example, the identity matrix is a diagonal matrix. For example, if we have I4, so it will be 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. So this diagonal here can be any element, but this element here, all these elements and all these entries here must be equals 0. So any matrix that has zeros here and at the main diagonal we have some numbers, we say it is a diagonal. For example, a matrix with 2 3 4 0 0 0 0 0 0 years, this is diagonal matrix. So this 0 is 4 is here, so this is a diagonal matrix. And even if we have 0, for example, here, or 0 here, so it's still a diagonal matrix. For example, this matrix here is a diagonal matrix. So for example, 0 0 0 0 0 0 0 0 2. So this is a diagonal matrix because all the entries here of the main diagonal, all these entries, are 0. So we say it is diagonal matrix. We define the upper triangle matrix as the matrix that have zeros below the main diagonal. For example, in this example here, we have all these elements are 0, but the other elements can be any number. So they can be zeros, can be any other element. The only condition here is to have zeros at these entries below the main diagonal, and we call it an upper triangular matrix. However, the lower triangular has element or has entries above the main diagonal equals 0. So these elements above the main diagonal, we have the main diagonal here, all these entries above it must be equal 0. And this element can be an element, can be zeros, can be 1s, 2s, any elements here. But the only condition is to have zeros above the main diagonal. Symmetric matrix is matrix that equals its transpose. So for example, we have here this matrix A, so its transpose will be A transpose equals, here it is 4 by 4. I want to note here that all these definitions are for just the square matrix. So if we have n by n matrix, number of rows equals the number of columns. However, for the n by n matrix, all these definitions are not defined. We can't get the diagonal matrix or upper triangular matrix or lower triangular matrix or symmetric matrix for the matrix that are not square matrix. So the transpose matrix of this matrix A is a 4 by 4 matrix, which has here the first column here of this matrix will be the first row here. So the first row here will be 2, 3, 6, 5. And this row here will be the second column here. The second row here, this is the first row, will be the first column. And the second column here will be the second row here. So this 3, 3, 7. So 3, 3, 7, 9. So this row here. And this third row here will be the third column here. So we'll get this 6, 7, 1, 3, 6, 7, 1, 3. And the third row or the fourth row here will be the first column here. So it will be 5, 9, 3, 0. So 5, 9, 3, 0. And this is the same matrix. So its transpose. So A here is equals its transpose. So A equals A transpose. So in this case, we say that matrix A is symmetric matrix.